Hello guys, today I'm gonna demo or show you some tips how to set up your AutoDustBoot with the RapidChangeATC. So now that most people receive their RapidChangeATC, especially on this and Maso controller, so a lot of my customer ask me how they gonna program their AutoDustBoot with the RapidChangeATC. Because if you already set up your RapidChangeATC successfully and also your AutoDustBoot, so the prerequisite first is you should be able to control your AutoDustBoot with the coolant flood. So in Maso, if you already connect that to the coolant flood, because what the requirements is we should be able to control the coolant flood using M8, which is turning on, and M9, which is turn it off. And the way we connect the AutoDustBoot is the same way we control that G code. In Onefinity Maso, they also leverage this to control your vacuum power. So so at the same time, you can also turn on the vacuum during this M8, M9 command. So now the idea is we want to retract the AutoDustBoot during the tool change. So if you're using the post processor of the Vectrix or whatever RapidChangeATC provided you, if you open the G code, like for example, I'll show it to you. I have one G code here that my customer provided in the screen. So in here, if you look on here, there's an there's a N200, which is a line 21. I believe the post processor for Masa always insert number. So N200 as a reference. There's an M98. In Maso, RapidChangeATC implementation right now, they use submodule. Although the new update from the Maso, they use the regular M6 command. On Gearball Hall, we use the M6 command as the normal tool change, but for the RapidChangeATC subroutine, they use M98 and followed by P63 and then followed by the tool number. So I'm not sure why this is 11 for my customer sample, but this is supposed to be, if you're using ATC, the stock one, there's only should be 4 pockets. So this should only be 1, 2, 3, 4. But just for the sake of this demo, let's just assume this 11 is a valid one. So the next number is N210, which is S1800, 18,000, which is spinning your spindle 18K RPM, and then followed by M8. So this is good. So it's already issuing an M08 command, which will expand the AutoDustBoot or return on your vacuum because it's connected to the coolant plug. Both are connected to the coolant plug. But if you notice, the beginning of the tool change, it doesn't retract the AutoDustBoot. So normally there should be an M9 here, and let's say just throw a number 91 M9. That's supposed to be every time we see M98, there should be M9 in here. So the programming will retract the dustboot first before executing the tool change, or there might be also if you need a delay to give some time before the AutoDustBoot to fully retract before start moving to the tool change. But usually M9 is sufficient enough. So this is one way to do it. But let me show you the better way. We're gonna use the RapidChangeATC service. So let's open the browser. I think I already have a RapidChangeATC. Log in here. Let me log in and enter my. Remember me, log in again. And here we're gonna go to my dashboard. So you guys already have this on your setup. So I'm gonna go to Master G3. And then I'm gonna open one of my profile. So here, open profile. And then in this hook, we need to add the hooks. Now, if you're not seeing this hook, you need to go to this gear icon and then turn on the macro hooks. So we're gonna use the before tool change. We want to turn off the coolant flood before the tool change. So that will retract our AutoDustBoot. And at the same time, we'll turn off the vacuum if it's also connected to that. So let's do an edit. So in here, let me actually remove this. So okay, so let's say you start from scratch because I already have some. So we're gonna add the execute G code. Just drag it, and then here we're gonna type M8. And if you notice why I said M8, it's supposed to be M9 because turn it up, but I'll explain it to you later on. So I'm gonna add another one. This one I'm gonna add a delay, which is G4 P 100 milliseconds. And then the last one is M9. This is the actual what we need. So why did I execute M8 then followed by G4 P100? So the reason is because the state of AutoDustBoot, the control doesn't know the state of AutoDustBoot. The reason we execute M8 is to guarantee that we're changing the state of the coolant plug. Because, for example, if it's already turned off and then we execute the M9, nothing gonna change, nothing gonna execute. So that's fine, but what happens if you lower your dustboot using the control knob? The controller doesn't know that you lowered the dust boot. So to safely actually force to retract it, we're gonna turn on the flood, coolant flood, and quickly we're gonna turn it off. So that guarantees that the state will change and that will trigger the auto dust boot to retract. It doesn't matter if the auto dust boot was retracted by coolant flood or by using the rotary knob on the auto dust boot. This and the G4. Why do we need a delay P100? Why can you just M8 and then M9 immediately? Why do we need a delay? Okay, the explanation of that is when I programmed the microcontroller of the AutoDustBoot, during my testing, some of the controller I measured this coolant flood. Sometimes it's susceptible for EMI, so there's a voltage spike that my microcontroller will pick it up. So they're like a very fast on off signal because there's a back voltage signal. So I create some coding to ignore the sudden change on this coolant flood signal. So anything that's 50 milliseconds change, it will be ignored. So if we don't have this delay, the M8, M9 changes that we send, it will be ignored by my AutoDustBoot. So for the save, I just add a peanut P100, and 100 milliseconds is very fast. Then we'll just submit, and then make sure you enable it. So here there's a disable, so uncheck it. Another one is after tool change. This is optional, but it's ideally we want to set this up too. If you saw some of my video, every time I do a tool change, after the tool change is done, when you do a tool measurement is done, it moves away from the magazine. The reason I added that is I don't move away, there's a tendency that the AutoDustBoot will start going down at the same time the X and Y start moving to continue or to resume the cutting. Ideally, I use a 150 millimeter or maybe 6 inches away from the magazine. So let's just enable these two. So in this one, I'm gonna add another G code, and this one will execute G53 for machine coordinates, G90 for, in my case, X150, which is 150 millimeter. So you can change this if you're using inches. And why I use X, in your case, you might use negative 150 or Y150 or Y negative 150. This value will depend on how you mount your RapidChangeATC or orientations. So in my case, I mount mine Y-axis. So I want to move it on the X direction. This is a number that you need to define by yourself. But the important is the G53 and X150, just for example. And then let's submit. In my case, I'm gonna remove the disable, apply. And then once you set this up, you click the download. And then follow the instruction, setting up your submodules. So I'm just gonna open the submodules. Now you see there's a before tool change and after tool change. The advantage of this, putting the M9, all your tool change will have that before tool change executed and also after the tool change executed. Unfortunately, I cannot demo this running because I don't have a Maso anymore. I sold out my Maso. I tried Maso, but it's just not for me. It's a preference by for individual, but in my case, it's not for me. Now let's go back to the situation where I told you like you have clamp that's spread out on your material. You know your G code won't go to that where the clamp is, but it might go when during the tool change, it might be a path where it goes back to the continuing cutting. So that's a problem. So our goal is we don't want to expand the AutoDustBoot after we finish the whole tool change and XY movement. So now I'm going to show you to some utility that I wrote. It's on my website, Francis Creation. The utility TS changer. So this is an online file. This is basically it's another post processor that I wrote. It's the reason I made this is more flexible for me to write this because this work on any compiles, most of the compiles. If it doesn't work, just report it to me because I can't predict all the compiles. But so far I think I did Fusion 360 and Batrix. So in our example, let's go back to this file. The same my customer sent it to me. So you look in the ideal is this M8 supposed to be after the first XY movement. So that's the ideal way to put the M8, the expansion. So what we're gonna do is where's this file? Reveal in Finder. It's on my download. Okay, that's good. So let's open that on the Chrome. Oh, and then I go to the download, and then cut polls too. So let me open it. So since we already did the before tool change command on the RapidChangeATC, we don't need to put M9. But that's another alternative. If you don't want to go to the hook approach, you can also put the M9. But like I said, this will only work with the current programming. It won't do their manual tool change on RapidChangeATC. And then the after tool change, this is okay. I added after tool change M8 G4 P1. I added a 1 second delay. Wait, I'm not sure if 1 or 1,000. So it's up to you. I'm not sure if it's a. I think if it's a Maso, I think it's using milliseconds. I forgot, but it's up to you. So P100. Let's say it's using milliseconds. So I'm gonna use a P100, and then ignore existing matching commands. So let's check this because our original file already has an M8. So let's check this. Not because if you don't, this will M8 will stay on that location. Actually, let me undo this. Okay, here. Save it, and let's generate a file. Oh, I don't have a permission. Okay, I don't know why I don't have a permission. So that's probably a permission issue. Let me open in a different browser. Let's try that again. Okay, here, I'm gonna use a Safari. Then I'll just choose file again. It's on download. Cut, pull to open, upload. Do this again. And for 1,000 and generate. Allow. Now it's generated. Let's look on my. There's some modified, so it's the same file name. Let's open this again here in your favorite editor. Now let's look and let's inspect that. So here there's again an M98P200, the spindle RPM, and then there's already a delay that's already part of the custom original file. And then look at here, the X and Y is executed, then the M8, then the delay, and then before it's resume the actual job, like it is a Z plunging here. So this is the ideal. So what will happen is after the last part of the tool change is do the tool measurement. Now if you did the suggestion of putting after tool change a move away, that will also be executed. And then after that, the spindle will move to the XY location to continue the job. Before it moves, spin the spindle to the RPM we desired for continuing the job. Move to the X and Y, and then the AutoDustBoot will go down, and then the spindles go down, and it start resume the job. So that sequence will avoid the hitting any clamp that like a very high clamp that you have on your material. Okay, if you have any question, just comment to this video and I'll try to answer as much as I can. By the way, this is actually a rapid change ATC. I'm just helping out my AutoDustBoot customer how to integrate it, because some of my customer also using different ATC like Monc and CATC. So this is like also I think this also instruction is also applicable to not just Onefinity. I think Gearball Hull also does the same thing, but instead of M98, like I said before, it's M6 command. Okay, now thanks for watching.